Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about an overview on probability and distribution. So very first thing is that what is probability? So probability is nothing but a chance that some event will happen, and it should be the ratio of number of ways of certain events to occur on to the possible number of outcomes. So probability is nothing but a chance that some event will happen, and it is the ratio of the number of ways of certain event can occur to the possible number of events. So if a something event is occurred, so number of times that event is going to be occurred by the total number of outcomes. So that is the definition of probability. So before going to see that, we have to know some of the basic terms like experiment and sample space. So what is an experiment? So experiment is any process so that generates well-defined outcomes, and the sample space of an experiment is the set of all expectable outcomes. And all an experimental outcome is also called as sample point. Okay, an experiment is any process that generates well-defined outcomes, and the sample space of an experiment is the set of all experimental outcomes. And this experimental outcome also known as sample point. So what are the events and the probabilities? So events is nothing but a collection of sample points, and the probability of any event is equal to the sum of all probabilities of the sample events in the event. And if we are going to identify all the sample points of an experiment, and we have to assign a probability to each, where we can able to compute the probability of the event. So event is nothing but a collection of sample points, and the probability of any event is equal to the probabilities of all the sample points in the event. Then, so what is an experiment and sample space? So experiment is nothing but a tossing a coin, and and inspection of a part, and then conduct a sales call, and rolling a dice, and play for a football. So these are the some of the experiments. So what is the experiment outcome here? So if I'm going to toss a coin, then I can able to get head and tail, right? So if I'm going to get head and tail, then that should be the outcome of this tossing the coin. And next one is inspecting a part. That means either it is a defective or it may be non-defective. And another one is conduct a sales call. That means purchases or no purchases. And rolling a dice, that should be 1, 2, 3, 4, 5, 6. And play a football, that should be win, lose, and then tie. So these are the some of the experiments, and that should be the corresponding experimental. So using simple events. So the probability of an event A is equal to the sum of the probabilities of simple events contained in A. Suppose if the simple events and experiments are equally likely, then you can able to calculate it as P of A. So where A should be the event in that, right? So the event is that probability of A. So I'm going to find the number of simple events by the total number of simple events. So suppose if I'm going to take uh, rolling a coin or toss a coin. So in this one, I'm going to get one is head and another is tail. So what is the probability of obtaining head? So this is the one event. So out of how many number of outcomes? Two outcomes. So 1/2. 1/2, that should be 0.5. Next one, die toss. So if I'm going to toss a dice, so what are the simple events here? Getting 1, 2, 3, 4, 5, and 6. So these are all the simple events here. So one event, if I'm going to roll a dice, I'm going to get 1. If I'm going to roll a dice, I'm going to get 2. If I'm going to roll a dice, I will get 3. If I'm going to roll a dice, I will get 4 and 5 and then 6. So these are the possible options where I can able to get it. So then sample space is nothing but set of all these events. Okay. So the sample space is the thing where you can able to get all the events. Then what is the event? So event is nothing but a collection of one or more simple events. So event is nothing but a collection of one or more simple events. Suppose a dice is going to be tasked where A should be an odd number, and another thing is the another event B that should be where the dice A should be greater than 2. That means, so if I'm going to roll a dice here, so what will happen? So I'm going to get 3 events. If I'm going to roll a dice on the thing, so what is the event is that should be number should be greater than 2. So in this one, so what I'm going to say, so I'm going to say that what is the if I'm going to roll a dice, what is the possible options? I'm getting an odd number here, 1, and then 3, and then 5, right? So these are the possible outcomes of an odd number, right? So what are the possibilities of getting uh, a number that should be greater than 2? So that means greater than 2 means, so 3 is the one option, and 4 is another option, and 5 is the another option, and 6 is the another option. So this is the event B, and this should be event B. So these are the events what I noted in this event. This is the sample space of that event. So if I'm going to draw this Venn diagram of these two events, so I can able to write. So what is this common in these two events? So that should be 3 and 5. Then here also 3 and then 5. So these 3 should be the common. So where, so E13135 is the event A, and then 3 3 4 5 6 3 4 5 and 6, that should be event B. So the common is that 3 and 5. What is the exceptional one? So event 2, that should be entirely different, not reflect to event A and B. So finding the probabilities, how are we going to find it? So the probabilities can be found using the estimation from the empirical studies and the common sense estimates based on equally likely events. So tossing a fair coin, so that thing should be written as probability of head. Suppose that the 10% of US population has red hair. So what is the person selected at random? So that means uh, 1 divided by 10, that should be 0.10. So 1 out of 10, that should be 0.10, 10% of the population. So let us consider another example. So tossing a fair 2 coin twice here. So what is the probability of observing at least one head? So that means at least one head I have to get it. So I'm going to toss 2 coin. So initially I am having 2 heads, right? So if I'm going to roll a one head here, so on the first coin is tail. So what is the second coin options what I'm going to get? So first I will get head and another is tail. If I'm going to take tail is the first one, so the second coin options will be head and tail. So totally 4 options I can able to get for tossing a second coin. So the events get what I'm getting here is 2 heads, head one, first head and second one is tail. and first one is head and both should be the tail. So what is the probability of this? So total number of outcomes equal to 4. So what is the probability of obtaining two heads here? So 1 by 4, 1 by 4, 1 by 4 and 1 by 4. So now what I'm going to say that is, so I want to find the probability of getting at least one head. So that is probability of at least one head means 1 by 4 plus 1 by 4. And one more thing is getting the even 3 also, totally 3 by 4. So like this we are going to calculate the probability of the event here. So now I want to find what is the probability of getting at two heads. So the only one event is there, that should be probability of E1. So I'm going to get the probability value of two heads is 4. Similarly, probability of two tails, probability of E4. So that should be 1 by 4. So let's consider another example. So a bowl contains 3 amps. Okay. So one is red and another is blue and another one is green. So a child want to select 2 amps at random. And what is the probability that at least one should be the red? So it's so the first option is three colors I'm having. So one is red, blue, and then green. So in the second amp, what I'm getting here is, so if it is red, the possibility will be blue and green. If it is blue, the possibility will be red and green. If it is green, I'm going to get red and blue. So these are the combinations what I'm going to get. So in this one, so what is the option here? Red and blue is one option, red green and blue red, blue green, green blue, and then green red. So totally how many events occurred? 6 events. So probability of what is the probability of getting this red and blue? So 1 by 6. Here also 1 by 6. 1 by 6, 1 by 6. And for all this, it should be 1 by 6. So now the question is that what is the probability of getting at least one red, right? So where I'm going to get red here, so that means, so this is the one of the option, red, red is there, and this red is there. So for the probability of RB, BR, RG, and G. So what is the probability here? So 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6. That should be 4 by 6. That should be 2 by. Similarly, another question what I'm going to discuss here is that, so what is the probability of getting green? So where green is there, so the probability of G plus probability of BG plus probability of GB and the probability of GR. So total I'm going to get 1 by 6 plus 1 by 6, and here also 4 by 6, that should be the probability is 3. And next one is that, so what is the multiplication rule and independent events? So the multiplication rule is going to be applied for the independent events. So where the outcome of one event should not affect the outcome of another event. So then two events are said to be independent events. Now, in mathematics, how can you write? So probability of A intersection B. So that should be written as probability of A into probability of B. So example, so flip a coin twice. So what is the probability of getting two heads? That is one of the questions. And another thing, what is the probability of getting head and tail? And one head is another option. So three computers are ordered. So what is the probability of getting working computer is 0.7, and what is the probability of all remaining three means? So 0.7 into cube. And next we'll see about event relations. So the beauty of this event using events is that rather than simple events, so we can able to combine the events to make other events using logical operations like and or and not. So normally we're going to have union intersection. So union of two events is nothing but the the outcome of event A I have to consider or I can consider the outcome of event B or both when experiment is going to perform, and I can able to write it as A union B. So this is the set of all the events and B is the set of all the events. So union means all the data what is there in both the events should be considered. So union means of all the events of all the operations, all the content of this both events. And one more thing is intersection of the events is nothing but it should be the common thing that is going to occur in A and B. So common thing is that this is the thing. The common thing is to be considered here. So how this one is going to write is A intersection B. So if A and B are mutually exclusive, then P intersection probability of A intersection B equal to 0. Sometimes you know that the probability that an event will not happen. So a event opposite to the event of interest is called complementary event. And if A is the event and its complement is going to be written as A cap, or I can able to write it as A power C, right? So here what I'm going to say, so this it is A, then A complement should be rest of this, and A should be the sample space. So how are we going to calculate the probabilities for unions and complement? So we're going to have an additive rule for this. So this additive rule states that so if I'm going to have the two events A and B, so the probability of their union should be write it as probability of A union B. So that thing should be written as probability of A plus probability of B minus probability of A intersection B. Okay, so these two are the events here. So probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. Here what I'm going to say that is uh, so if A and B are mutually exclusive, they should be 0. So then probability of A and B equal to probability of A plus probability of B. So what is this additive rule? Suppose we are going to have 120 students in our classroom, that could be classified as like this. So we are going to have male people, so total 60, female is 60, and in this one, so 20 should be the 20 hair color, brown color, and remaining 40 are not brown, and female in 30 is there. So this is the data what we are going to have. So what is the probability of getting brown hair? That is one of the in case of male. So what I'm going to get? So 50 by 120, and female is that 60 by 120. Why? Because there will be total of 120 students here. So in this 120 students, so what is the probability of getting brown hair? So 50. So that it should be 50 by 120. And what is the probability of getting male? Female. So that should be 60 by 120. So substitute these values in this equation. So probability of A and B equal to probability of A plus probability of B minus probability of A intersection B. So the probability of A should be 50 by 120. Probability of B is not brown, right? So not brown, it should be 60 by 120, and then A intersection B. So that should be common in the thing. That should be, I'm going to get it as 30 remaining thing. By substituting this, I can able to get 80 by 120. That should be 2 by 3. So the probability of A union B equal to 20 plus 20 plus 30 by 120. And special case is that so whenever the two events are mutually exclusive, So I can able to say the probability of A intersection B equal to 0. So this probability of A union B comes probability of A plus probability of B. So the probability of A is that, so male with brown hair, so that is 20 by 120, and B is that female with brown hair, that should be 30 by 120. So by substituting this value, so probability of A is 20 by 120, B is 30 by 120. So I can able to get 50 by 120. So calculating the probabilities for the complements. So we know that for any event A, so I can able to write probability of A intersection A complement equal to 0, since either A or A complement must occur. So what is that is the probability of A union A cap it should be 1. So that the probability of A union A cap is equal to probability of A into probability of A cap. So then automatically, so A complement is equal to 1 minus P of A. So the complements, so P intersection probability of A intersection A complement equal to 0, since either A or A complement must occur. So the probability of A union A cap equal to 1. So how can I able to write it? So probability of A plus probability of A cap equal to 1. So probability of A cap equal to 1 minus P of A. Then conditional probability. So the probability that A occurs given that B occurred is called conditional probability. So the probability of A occurred given that even B has occurred. That should be conditional probability. And it should be defined as probability of A by B equal to probability of A intersection B by probability of B if B is not equal to 0. So the probability that A occurred given that B occurred is called conditional probability, and B should be given it as probability of A by B equal to probability of A intersection B by probability of B if B not equal to 0. So example 1, so consider an example. So toss a coin, fair coin twice, so where A should be head on second toss and B should be the head on first toss. So head on second toss and B should be the head on first toss. The probability of A by B equal to 1 by 2, and probability of A divided by not B, that should be 1 by 2. Okay, so normally in previous slide I explained what are the probabilities of all the events. So the probability of A means does not change whether B happens or not, then A and B are the independent one, right? So in this one, so a ball contains 5 amps, 2 red and 3 blue. So in this one, randomly have to select the 2 candies. So define that the second candy should be red, and first and even B is that the first candy should be blue. So that means, so the probability of A by B equal to probability of second red and B is first blue. Probability of A by B by A. So that should be 2 by 4. That should be 1 by 2. So probability of event A not B. That means the second one is red and first one is red. So that should be 1 by 4. That means the probability of A does not change depending on whether B is happens or not. So the probability of getting A is second candy is red. So 2, and second one is B by A. In this one, so probability of A not B, that means the probability of getting second red not involvement of B, so first red, that should be 1 by 4. See this, I'm going to toss a pair dice. So given the first die should show 1 and the second one is that the green dice show 1. So what is the probability? So that means the probability of A by B equal to probability of A intersection B by probability of B. So the probability of A and B should be written as probability of A and B by probability of B. So here what I'm going to say that is the probability of A does not change whether B happens or not, and when B are independent. So see the cases. So the die one going to show red and green one. So green one and red one. So this is the die probability of event A showing the reds one, and this is the probability of all the events showing green one. So the probability of A intersection B, so I can able to write it as 1 by 36, and P of B write it as 1 by 6. So total I'm going to get 1 by 6, that should be probability of A. So toss a pair of dice. So define that add to 3 and add to 6. So probability of A by B equal to probability of A intersection B by probability of B. So what is the probability of getting 3? So nothing is there. So 0 by 36. And probability of B is 5 by 6. So totally that means so 1, 2, probability of getting 3 here, not involvement of B, right? So that means I'm going to get, so totally probability of A intersection B is 0 by 36, so probability of A is 5 by 6. And next we will see about the types of probability distribution like Poisson, nominal, and then binomial. So what is the distribution here? So the distribution is nothing but two types, so frequency distribution and then probability distribution. Frequency distribution means it is the listing of observed and actual frequencies of all outcomes of an experiment that actually occurred when experiment was done, and it is the listing of all the probabilities of all the possible outcomes that could occur if experiment was done. So frequency distribution means it is the list of observed or actual frequencies of all the outcomes of the experiment that actually occurred when the experiment was done. And probability distribution means it is the listing of all the probabilities of all possible outcomes that could occur if the experiment was done. So that is the difference between the frequency and the probability. So frequency means that it should be the listing of observed and actual frequency of all outcomes, but here in probability it is a listing of probability of all possible outcomes that could occur when experiment was done. And this probability distribution can also be shown in the form of diagram, what we call as probability diagram table. I can able to represent, I can able to show by making use of this mathematical form. So there are different types of distributions like probability distribution, like discrete probability distribution and continuous probability distribution. Again, this discrete probability distribution can be written as binomial and Poisson. So what is the binomial means and Poisson means? So binomial distribution and then Poisson distribution we'll see detail about in future slides. And the normal discontinuous are going to see about this normal distribution. So probability distribution means so discrete distribution. So like the random variable can take only the limited number of values. So that should be discrete one. Where the random variable can take any value. So that should be the continuous one. So discrete means, so example, so the number of heads in two tosses. So what are the options here? So only this. So there should be three, but here the height of students in the class, that should be one is one 5.0, 4.2, 4.3, 4.2. So like this, it's going. The values are going to be changed according to the time. So that's thing when we are able to call it as continuous distribution. So this is the tree diagram. So I can able to represent it. So if I'm going to toss a first coin, and this should be the second coin. So if I'm going to toss the first coin, so what I'm able to get, I'm going to get um, first head and second one is tail. So what the second coin I can able to get for options is that so head and tail, and if the first one is tail, I can also get head and tail. So the total event is two heads. So one head and one tail and two heads. So these are the four possible outcomes here. So next I'm going to attach the probabilities the tree diagram. So I'm going to get what is the probability of getting head. So two events, so 1 by 2. So here also 1 by 2. And for this also, what is the probability of getting head here? So 1 by 2, 1 by 2. So for this one also 1 by 2. So what is the probability of getting this one? So 1 by 2 into 1 by 2, that should be 1 by 4. So here also 1 by 2 into 1 by 2, that should be 1 by 4. And also 1 by 4. And here also 1 by 4. So like this, we can able to get the probabilities of individual events. So then how are we going to calculate these probabilities of at least one head? So this is the question they are given. So in this one, so what is the probability of getting at least one head? So this is 1 by 4, probability value is 1 by 4, and this one is also 1 by 4, and this one is also 1 by 4. So this is the three options we have and getting heads here. So in this one, so option is 3 by 4. And discrete distribution, so we are going to have one more example like tossing a three coin three times. So three times if I'm going to get, so what are the probabilities? So all the three coins should be head. That is the first option I'm going to have. So again I'm going to get, so these are the, so the first coin is head, so remaining all the chances are changed here. So if first coin is tail here, so then I can able to get so head, so again head's tail and tail head and tail tail. So this is the first coin is tail, then in this case the first coin is head in this case. So what is the probability of getting at least one head? Zero head. So that means what is the probability here? X is the event, so represents the number of heads, right? So that means zero heads. So what is the option I'm going to have? This one. So I can able to write how total number of events is 8 here. So the only one option I'm getting. So 1 by 8 I'm going to write it. So what is the probability of getting one head? So what is the one head? What is the frequency here? Uh, so this one head, right? 1, 2, and then 3. Um, 3. So not this one. At least one head, right? So 1, 2, and then 3. So what is the frequency here? 3. So I'm going to write 3 by 8. So what is the probability of getting two heads? So in this one, what is the option we're going to have? We're getting two heads. Uh, so this is the one, and this is the one, and this is the one. So 3 by 8. So the probability value is 3 by 8. What is the probability of getting three heads? So that is the frequency 1. So that is only 1 here. That should be 1 by 8. So like this, we are going to calculate the probabilities of all the events here. And next one is that binomial distribution. So this should be a certain phenomenon in nature where we are able to identify it as Bernoulli's process. In this one, there should be a fixed number of trails that should be carried out, and then each trail should have only two possible outcomes, say success or failure, or can able to write true or false. So the probability of occurrence of any outcome remains same over, and the trails are should be success and statistically independent one. So in binomial distribution, there should be the discrete Poisson distribution where you can able to express the probability of one set of alternatives that should be either success or failure, and the probability equation is going to be write it as so probability of NCR by P power R into Q power n minus R. So this is the equation you have to be remembered in the binomial distribution, which should be a discrete probability distribution. So mainly this one is going to be considered when I'm going to have like either true or false, or I can able to add the event should be either success or it should be failure. Then I have to apply this. So where n should be here is that number of trials undertaken, and r should be number of success desired, and p should be the probability of success, and q should be the probability of failure. So we have to remember all these terms. The next one is that Poisson distribution. So in Poisson distribution, what I'm going to say that is, so when there is a large number of trails here, but small probability of success, then the binomial calculation should be impractical. Okay. So whenever there should be a large number of trails and the small probability of success, then binomial calculation should be impractical. So this is the disadvantage, right? So at that time, so what I am going to do is I have to go for the Poisson distribution. So what is this Poisson distribution is, so P of x equal to lambda power x into e power minus lambda by x factorial. What is this lambda? So lambda means the mean number of occurrences of the event per event interval of time. Okay, so the lambda means the mean number of occurrences of event per unit interval of time or space. So where a should be the numpire constant, and this value is given by 2.7182. Okay, so when I'm going to use this Poisson distribution, so whenever the number of trails is large and probability of success it should be less, and at the time and we'll have to go for this Poisson distribution. So what are the characteristics of this Poisson distribution? So it should be a discrete distribution, and the number of occurrences are statistically independent, and the mean number of occurrences in unit proportion should be the size of the unit here, and the mean is going to be written as n into p, that should be denoted as lambda, and standard deviation should be the square root of lambda is equal to square root of np, and it should be always right skewed, and the Poisson distribution is good approximation to the binomial distribution whenever the number of trails should be greater than or equal to 20, and this probability value should be less than or equal to 0.05. So these are the characteristics of the binomial distribution. The binomial distribution means it should be the discrete distribution, and the number of occurrences are statistically independent, and mean number of occurrences in a unit of time should be proportional to the size of the unit, and the mean of the Poisson distribution is lambda into p, and the standard deviation is pd, so that means where square root of lambda is equal to square root of np, and it should be a right skewed, and where the probability should be less than 0.05. And next one is that for normal distribution. So what is this normal distribution? So it should be a continuous Poisson distribution. So that means where the random variable can take any number of value within the given range. Okay, suppose height, weight, and then marks. So that means the height of baby. So it may be, so in first month it should be 2 meters. It will be 1 meter. Then 1.1, 2.2 meters, 3. to 1.3. So like this the height is going on changing, right? So at that time I have to go for continuous Poisson distribution, that should be normal distribution. So mainly this one developed by mathematician, 18th century mathematician called it as astronomer or Gauss. So which is also called as Gaussian distribution. So normally this should be the symmetrical and unimodal approach. So well, you can able to get only one peak here, and since it is symmetrical, so its mean, median, and mode all should be the coincides. So that means all the three should be same here, and the tails are asymptotic to the horizontal axis, so that the curve goes in infinity without touching the horizontal axis. So here the x represents the random variable like height and weight, and y represents its probability density function. So the area under the curve tells the probability, and the total area under the curve is 1, that should be either 1 or 100%, and the mean should be this mu, and standard deviation should be the sigma. So this normal distribution means it should be a continuous probability distribution where the random variable can able to take any value within the range. For example, height, weight, and mass. Normally, this one is introduced by the 18th century mathematician Carl Gauss, which is also called as a Gaussian distribution, and it is symmetric and unimodal approach. And this is the symmetric. The tail. No, what I'm going to get. The tail are asymptotic notations and to horizontal axis, and the x-axis represents the random variable like height and weight, and the y-axis represents the probability density function. So x should be this random variable. This should be the probability density function. So normally we're going to get the curve, and this curve, the area under the curve tells the probability of this one. So the mean value should be written as mu, and standard deviation should be written as sigma here. So how are we going to define this normal distribution? So the two parameters are going to be considered. So first one is mean, and then second one is standard deviation. So the same mean, different standard deviations is going to be considered. Same standard deviation, different means, and different mean and different standard deviations. Next we'll see about the discrete and random variables. So what is this random variable? So random variable usually written as x, and where the possible values are the numerical outcomes of the random phenomenon. And there are two types of random variables, like a discrete random variable and continuous random variable. So this random variable means whose possible values are the numerical outcomes of the random phenomenon. Basically, it should be two types, so discrete and then continuous. So what is this discrete random variable? So discrete random variable is one which may be able to take only the countable number of distinct values like 0, 1, 2, 3, 4, and these discrete random variables are usually counts. For example, so the number of children in a family, and Friday night attendance at the cinema, a number of patients a doctor see in a day, a number of defective light bulbs, and number of cats flipped. So this should be the discrete random variable. So the countable number of distinct values should be considered as discrete random variables, and usually the counts is going to be considered in discrete random variable. So the discrete random variable takes the fixed set of possible values with the gaps between them, and the probability distribution of discrete random variable x lists the values and the probabilities like this. So we're going to have a set of values, and each and every value there should be a corresponding probability. So for every probability pi, the value should be in between 0 and 1 only, and where the sum of all probabilities should be 1. And in order to find the event of any event, so we have to add up all the probabilities of particular values to make up the event here. So for finding this discrete random variable, so we're going to have set of values and the probabilities. So the main requirement is that the probability should be always lies between 0 and 1, and the sum of all the probabilities should be less than 1 only. So if I'm going to construct a graph like this, so we're going to follow. So here epigar square I'm going to consider, and probability I'm going to take, and between one random variable what is the probability, second, third, fourth, like this I'm going to construct the bar of here, and the probability distribution should be constructed by using bar graph. For continuous it should be line graph. So to calculate the mean of the discrete variable and like this, suppose if you are going to have an x random variable, so whose probability distribution is this and probability value is this one. So how are we going to calculate the mean? So mean is nothing but the expected value. So where it should be the sum of all the products of this, and mean of x should be written as a of x, that should be x1 into p1, x2 into p2, and x2 into p3. Then simply I can able to write sigma xi into pi, right? So to find the mean, then we have to multiply each possible value by its probability, then add all the probabilities values. So that means the probability of xi in p1 and x2 in p2 and x2 into p3. So that should be written as xi into pi. And standard deviation of discrete random variable, suppose that x is a discrete random variable whose probability distribution is this one and probability is this one. So the mean of x should be written as variance of x. So that means the variance of x should be written as sigma x square. So how can you write x1 minus mu value whole square into p1. And similarly I can write x1 minus x2 x2 minus mu whole square into p2, and x3 minus mu whole square into p3. So like this we're going to calculate, and sigma x minus mu whole square into pi. And next one is continuous random variable. So in continuous random variable is one which can able to take infinite number of possible values, and the continuous random variable are usually measurements. Example, height, weight, and amount of sugar in an orange, and the time required to run a mile. So this continuous random variable is one which is going to take infinite number of possible values, and this continuous random variable are usually measurements like height. So I can able to measure in centimeters, weights in kgs, and amount of sugar in kg, and the time required to run seconds or whatever it is, hours or minutes. So this continuous random variable x is going to take all the values in interval, and the probability distribution is going to be described by the density curve, and the probability of any events in the area under the density curve are about values of x can able to make up this event here. So if I'm going to consider the height in x-axis and then hash on y-axis, I can able to get this. So here what we're going to construct is line graph. In normal distribution, I have to construct bar graph here. So this is the area under the curve should be considered as the probability of this. So the continuous random variable is not defined as specific values. So instead it is defined over the interval of value. However, we can able to calculate the probability of the continuous random variable. So here this continuous random variable is not defined as specific values. So instead it is defined over interval of value, and so it should be similar to the z score and the normal distribution calculations. So in normal distribution calculations, we're going to consider this here. So when it comes to conditional probability like Bayes theorem, so what is this conditional probability? So when we want to find the probability of event, distribution, we're going to write it as probability of B by A. So it should be defined it as probability of B given A. The probability that takes into account the given condition is called probability. The probability that takes into account a probability that takes into account a condition is called conditional probability. So when I'm going to find the probability of an event from the conditional distribution, then we can able to write it as probability of B by A. So the probability that takes into account a given condition is called conditional probability. So let us find how we're going to, what is the equation for finding this conditional probability. So to find the probability of event A given event B, then we can able to restrict our attention to outcomes where we can able to find it as probability of B by A is equal to probability of A and B by probability of A. So the probability of A intersection B by probability of A. So where P of A not equal to 0, since we know that A has occurred. What's the next? We'll see about the Bayes theorem. So what is this Bayes theorem? So the Bayes theorem is also known as Bayes rule, or can we write it as Bayes law or Bayesian reasoning. So which is going to be determines the probability of an event with uncertain knowledge. So in probability theory, it relates the conditional probability and marginal probabilities of two random events. So the Bayes theorem was named after the British mathematician called Thomas Bayes. So the Bayesian interface is an application of Bayes theorem which is the fundamental to the Bayesian statistics. So Bayes theorem, also known as Bayes rule and Bayes law and Bayesian reasoning, so which determines the probability of event with uncertain knowledge. And in this probability theory, it relates to the conditional probability and the marginal probabilities of two random events. So normally this Bayes theorem known as British mathematician Bayes, where should be the application of Bayes theorem. So what is this Bayes theorem? So Bayes theorem is the method of calculating the conditional probability, and this should be the traditional method for calculating conditional probability that one event occurs with the given occurrence of different event that should be used to the conditional probability value. So calculating this joint probability of event, so an event 2 so occurring at the same time, then we have to divide it by the probability of event. So however, the conditional probability can be calculated slightly in the different fashion by using the Bayes theorem. So the Bayes theorem is the method of calculating the conditional probability, and the traditional method of calculating this conditional probability is that an event occurs with the given occurrence of different that should be used the different conditional probability formula, and then we have to divide by the probability of event 2 occurring. So the conditional probability can be calculated in slightly different fashion by using the Bayes theorem. So when calculating this conditional probability with the Bayes theorem, so we have to follow some of the steps. So first we have to determine what is the probability of condition being true, assuming that condition A is true. Then we have to determine what is the probability of event A being true. Then we have to multiply the probabilities of both together, and then we have to divide by the probability of event B occur. Then I can able to get the equation like this. So the probability of A by B equal to probability of B by A into probability of A by probability of B. So this should be the formula what we have to be remembered in terms of Bayes theorem, where you can able to express like this. So probability of A by B equal to, so probability of B by A into probability of A by probability of B. So the Bayes theorem is further derived using the product rule and the conditional probability of the event with the known event B. So as we know that the probability of A intersection B equal to probability of A into probability of B, and the probability of event B with known event A can be written as probability of A intersection B equal to probability of B by A into probability of A. So by using these two formulas, we have to be substitute this one into above equation. So that means, so the probability of A by B can be written as uh, probability of B by A into probability of A by probability of B. So in this one, the probability of A intersection B is I can able to write. So okay, where I can able to get probability of B by A equal to we have to substitute this probability of A by B equal to here issue A by B, right? So A by B equal to probability of A intersection B. So I'm going to write probability of A B by E and probability of A by probability of B. So what I'm doing here is that, so in this I'm going to substitute this equation. So I'm obtaining this one, that should be probability of A by B. So that means probability of A intersection B by probability of B have right. So what I'm going to get, so the probability of, so probability of A intersection B by probability of B. So the probability of B equation is given by this. So I'm going to write probability of A by B by A into probability of A by probability of B. So this should be the derived Bayes theorem equation what we have to be remembered. So the above equation what I'm showing that should be called as Bayes rule and Bayes theorem. That should be the basics of modern AI systems for the probability inference. So in this equation, so some definite terms is there. So the probability of A by B can be written as posterior form, and probability of B by A can be written as likelihood, and the probability of A should be the prior one, and probability of B can be written as marginalization. So these are the set of equations that we have to be considered here. So the Bayes theorem. Uh, so probability of A by B can write it as posterior, likelihood, prior, and marginalization. Normally, it is going to show the simple relationship between the joint and then conditional probabilities. So where P of A can be written as posterior, where we need to calculate thus, and it will be written as the probabilities of hypothesis A when we are going to occur and evidence B. So the probability of A by B is the posterior. So why? Because we need to calculate, and this should be written as the probability of hypothesis A when will occur and evidence B. And probability of B by A is called as likelihood. So when we are going to consider the hypothesis true, then we are going to calculate the probability of evidence. So the probability of A should be written as prior probability because the probability of hypothesis before considering this evidence. And probability of B should be written as marginal probability, which should be pure probability of evidence. So that's why we can able to write the probability of B can be written as uh, probability of A into probability of B by A. And finally we can able to get as the probability of A by B should be written as probability of A into probability B by A and summation of probability of A into probability of B by AI. And next we will see about chi-square test and then t-test. So in this one, the parametric test, some of the terms you have to be remembered here, like parametric test or non-parametric test and hypothesis. So parametric test is the one in which we are going to choose the population constants like mean, standard deviation, standard error, correlation, coefficient, and proportion. And data tend to be assumed or established distributes such as binomial or Poisson distribution. So it is defined as the definite statement about the population parameter. A null hypothesis is the thing which is going to be states that no association exists between two cross-tabulated variables in the population, and therefore the variables are statistically independent. An alternative hypothesis proposes that the two variables are related in the population. If we are going to assume that the two methods A and B should be superior than the method B, then this assumption is called alternative hypothesis. And next, we are going to see about the degrees of freedom. That means it going to be denotes the extent of independence enjoyed by the given set of observed frequencies. And suppose that there are n set of observed frequencies, and which are going to be submitted to k independent constraints. So here, the definite terms can be degree of freedom can be defined as the number of frequencies minus number of independent constraints on them, and they should be given by the equation degrees of freedom is equal to r minus 1 into c minus 1. And the contingency table is the table which is going to be prepared by the enumeration of qualitative data by entering the actual frequencies. And if there the table represents the occurrence of two events, then it is called contingency table. So it's a chi-square test. So chi-square test is an important test among the several tests of significance defined by the statisticians. And the chi-square test is a non-parametric test, not based on any assumption or distribution of any variable. And the statistical test follows the specific distribution known as chi-square distribution. And in general, the test what we're going to measure the difference between that observed or expected according to the hypothesis called chi-square test. So this importance is that it is going to be used as non-parametric test, and it should be used for testing hypothesis and not for useful for estimation. And this test is going to be applied to the complex contingency table. So this should be the graph that should be obtained in chi-square distribution. And if the degrees of freedom is greater than 2, then distribution is bell-shaped. And if the degrees of freedom equal to 2, then the distribution is L-shaped with maximum coordinate at 0, and distribution should be L-shaped with the infinite ordinate should be less than 2. So this is the equation what we are going to calculate in chi-square test. So chi-square is equal to sigma O minus E whole square by E. So where O should be the observed frequency and E should be the expected frequency. So what is t-test? So t-test is going to be used for comparing the mean values for the two set of numbers, and comparisons will be provided at the statistic for evaluating whether the difference between the two means is statistically significant. And the null hypothesis is going to be used that states that any difference between the two means is the result of difference in distribution. So comparing that the chance having difference of one group should due to the difference in distribution as well. So this one in t-test to find the difference between the chance, so the variability and sample size is going to be constructed. So there are different types of sample tests like one sample t-test, independent sample test, and paired sample t-test. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.